Good morning. It's August 9th, and this is your daily brief in science. Here's everything you need to know. Researchers have reached a remarkable milestone in geoscience by drilling the deepest sample of Earth's mantle, reaching 0.7 miles, or 1.2 kilometers, below the mid-Atlantic ridge. This significant drilling project took place at the Atlantis Massif, an underwater mountain, using the JOIDES resolution vessel from April to June 2023. The team successfully recovered a 4,160-foot-long core of peridotite, achieving a 71% recovery rate of the drilled material. During the spring 2023 Expedition 399, titled Building Blocks of Life, researchers extracted nearly continuous 1,268 meters of mantle rock from a tectonic window along the mid-Atlantic ridge. One of the key findings was that the interaction between seawater and mantle rocks releases hydrogen, which can lead to the formation of compounds like methane that support microbial life. The samples collected provide valuable insights into crust formation processes, as the mantle has pushed through the seafloor at the Atlantis Massif. Led by Johan Lissenberg from Cardiff University, the research team initially set out to drill 200 meters but continued to a depth of 1,268 meters due to the promising results. Rosalind Coggan described the expedition as a fantastic landmark in ocean drilling, emphasizing its importance for understanding Earth's formation and evolution. This successful drilling not only sheds light on the processes that feed oceanic volcanoes, but also on the potential origins of life. However, this achievement is bittersweet, as the JOIDES resolution, the vessel used for this groundbreaking work, will be retired due to funding issues. This raises uncertainties for the future of ocean drilling, even as this project marks a significant milestone that could pave the way for deeper explorations into the Earth's layers. A recent study has revealed an astonishing 747 different genera of bacteria lurking in the microwaves of American households. Led by Alba Iglesias at the University of Valencia, the research utilized next-generation sequencing and cultivation techniques to identify these bacteria, which belong to 25 different bacterial phyla. Among these, firmicutes, actinobacteria, and proteobacteria were found to be the most prevalent. Despite the fact that microwave ovens are present in 90% of U.S. households, a significant concern arises as 1 in 3 Americans neglect to clean them weekly, as recommended. Belinda Ferrari from the University of New South Wales emphasizes the necessity of regular cleaning, reinforcing the study's findings that bacteria can adapt to various environments. Co-author Porkar also stresses that microwaves do not eliminate microbial contamination on their own, making cleaning essential. Experts recommend using diluted bleach or disinfectant spray for cleaning, along with sanitizing surfaces after each use to reduce bacterial growth. The study indicates that while microwaves are not sterile, they do not serve as major reservoirs for pathogens, although they can harbor nearly 750 different species of bacteria, some of which may pose health risks. Among the identified strains, 101 were specifically noted, with dominant genera including Bacillus, Micrococcus, and Staphylococcus, which are typically found on human skin. Notably, Klebsiella, a bacterium often associated with human feces, has been identified in these environments and poses serious infection risks, particularly as it is becoming increasingly antibiotic resistant. The research suggests that these resilient microorganisms could have potential applications in cleaning up toxic waste, highlighting their adaptability. Further research is needed to explore the adaptations of these strains and their potential applications in industrial processes or as biocatalysts. A recent study has raised concerns regarding erythritol, a sugar substitute commonly used in various food products. The research indicates that erythritol may increase the risk of blood clotting, a finding that could have significant health implications. Dr. Stanley Hazen, the lead author of the study, highlighted that while glucose consumption does not affect platelet activity in the same harmful way, erythritol does. Increased blood clotting is associated with serious health risks, such as heart attacks and strokes, especially for those already at risk for these conditions. This research emphasizes the need for further investigation into the health impacts of sugar substitutes that are widely consumed. However, the study's limitations include a small sample size and a single measurement of effects, suggesting that more longitudinal research is necessary. Erythritol is popular in the US and Europe, known for being about 70% as sweet as sugar and produced through corn fermentation. It is classified as generally recognized as safe, GRAS, by both the FDA and the European Food Safety Authority and is often found in low-calorie and keto products. Dr. Hazen has advised that individuals at high risk for thrombosis might be better off choosing occasional sugar-sweetened treats instead of those sweetened with erythritol. The growing interest from food regulators, especially in Europe, is leading to recommendations for further data collection on the safety of erythritol. Ongoing research is also focusing on identifying factors that contribute to cardiovascular risk, including gut microbial pathways linked to heart disease. Despite these concerns, the Calorie Control Council continues to defend erythritol's safety, citing decades of research that support its use as a sugar substitute. ESA's Gaia mission has made a groundbreaking discovery, identifying potential moons around more than 350 asteroids that were previously thought to be moonless. This research, led by Luana Liberato from the Côte d'Azur Observatory, utilized data from Gaia's third data release, examining over 150,000 asteroids for signs of gravitational interactions that indicate potential moons. If verified, the identification of 352 new binary asteroid candidates could nearly double the current number of known asteroid binaries, which stands at about 500. Timo Prusti, the Gaia project scientist at ESA, emphasized the mission's significant role in enhancing data quality and enabling groundbreaking scientific discoveries. Studying binary asteroids provides unique opportunities to gain insights into the physical and chemical processes involved in the formation and evolution of planetary bodies. Current data from over 150,000 asteroids allows researchers to look for a typical wobble indicative of double asteroids caused by the gravitational pull of a companion asteroid. Gaia's advanced technology enables more precise identification and characterization of celestial objects compared to historical ground-based methods. The mission's Data Release 3 has refined asteroid orbit measurements by 20 times, with further insights expected from the upcoming Release 4, anticipated by mid-2026. Additionally, the upcoming Hera mission, set to launch in October, aims to evaluate the impact of NASA's DART mission, which successfully tested asteroid deflection techniques in 2022. The Gaia mission ultimately aims to measure the positions, movements, distances, and brightness of nearly 2 billion celestial bodies, significantly advancing our understanding of the solar system. Studying asteroids is crucial as they are remnants from the early solar system, providing insights into its formation over 4.6 billion years ago. A recent study has reshaped our understanding of elapoid snakes, including cobras and mambas, revealing that they first emerged in Asia approximately 35 million years ago. This research, published in the Royal Society Open Science, indicates that these snakes migrated to Africa around 30 million years ago, following their initial evolution in Asia. The study analyzed DNA from 65 snake species while integrating data from an additional 434 species to construct an elapoid evolutionary tree. This comprehensive analysis highlights the diversity of elapoid snakes, which includes over 700 species found in tropical and subtropical regions worldwide. The research team, made up of evolutionary biologists from the University of Kansas, the American Museum of Natural History, and the University of Helsinki, established that the Elapidae family originated in Asia, challenging earlier beliefs of an African origin. Previous studies had suggested an African origin based on limited genetic data and fossil records, but the new genetic evidence contradicts this notion. The analysis revealed that members of the Elapidae family did not appear in Africa until about 5 million years later, colonizing the continent in 4 distinct waves. This research challenges the long-standing out-of-Africa hypothesis regarding elapoid snake evolution and reshapes the understanding of their origins. These findings hold significant implications for both evolutionary biology and medical research, particularly in the study of snake venom and its applications. The researchers noted a lack of comprehensive data on the evolutionary history of the elapoid family, which led to unreliable conclusions in earlier studies. The team's findings effectively refute the notion of an African origin for the Elapidae family, asserting that their true origin lies in Asia. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. We'll be back Monday with everything you need to know.